Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see few problems on Laplace transformation. Let us start with problem number 1. Obtain the Laplace transforms of the following functions, out of which first is sine 2t into sine 3t. In the previous videos of Laplace transform, we have seen different types of properties and formulas. So we are going to implement it one by one. In the first case, we have sine 2t into sine 3t. Whenever we have product of sine and cos, or sine and sine, or cos and cos, we need to use the formula 2 sine a cos b or 2 sine a sine b. 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. Similarly, if I write it as 2 sin 2t into sin 3t, this will give you cos of 2t minus 3t minus cos of 2t plus 3t. Now 2 minus 3 will give you minus 1, but cos of minus theta is cos theta only. So we have cos t minus cos 5t. So to find Laplace of sin 2t into sin 3t, we can write it as Laplace of 1 by 2 into we have cos t minus cos 5t. In the next step, we can separate the Laplace to both the terms. This will give you Laplace of 1 by 2 cos t minus Laplace of 1 by 2 cos 5t. Now we can take constant outside. Now we know that Laplace of cos at is given as s upon s square plus a square. Here in first term the value of a will be 1 and for second the value of a will be 5. So this will give you s upon s square plus 1 square, that is 1 only. Laplace of cos 5t will give you s upon s square plus 5 square will give you 25. On further solving, you can take s common and 1 by 2 common from both the terms, that is s by 2. So we have 1 upon s square plus 1 minus 1 upon s square plus 25. Further we can solve this using cross multiplication. This will give you s by 2 into s square plus 25 minus s square minus 1 upon s square plus 1 into s square plus 25. Here s square will be cancelled. We have 25 minus 1, that will be 24. While the remaining part remains the same. Therefore the final answer will be 12s upon s square plus 1 into s square plus 25. Now let us see the second problem. Here we need to find Laplace of sine square 2t. Now sine square 2t can be written as 1 minus cos 4t upon 2. Taking 1 by 2 constant, we have Laplace of 1 minus Laplace of cos 4t. Laplace of 1 will give you 1 by s and Laplace of cos 4t will be s upon s square plus a square. Here the value of a is 4, so its square will be 16. On further solving these two fractions, we have s square plus 16 minus s square upon s into s square plus 16. S square will be cancelled. We have 2 ones are 2 8s are. So final answer will be 8 upon s into s square plus 16. Now let us see the next problem. Obtain the Laplace transforms of the following functions, out of which first is t square into e raised to 3t. Laplace of t raised to n is given as n factorial upon s raised to n plus 1. Similarly, if I find Laplace of t square, this will give you 2 factorial upon s raised to 2 plus 1, that is equal to 2 upon s cube. But whenever t square is multiplied with e raised to 3t, we can use the shifting property, where the value of s will be replaced by s minus 3. So using shifting property, we have replaced s with the power s minus 3, while the remaining part remains the same. Now let us see the second problem. Here we need to find Laplace of t into cos 3t. Now the standard function of Laplace cos 3t, we know it is s upon s square plus 3 square, that is 9. Now let us consider this function as f of s. Whenever t is multiplied to a trigonometric ratio, we can use the multiplication property, which says minus 1 raised to 1 d by ds of f of s. If we have t square, this will become minus 1 raised to 2, and this will be second derivative of f of s. Derivative of f of s, meaning derivative of s upon s square plus 9, can be found out using u upon v rule, which says v as it is, derivative of s with respect to s will be 1 minus s into derivative of s square plus 9 will give you 2s upon we have v square. On further solving, this will give you minus 1. We have s square plus 9 minus 2s square. S square minus 2s square will give you minus s square, and that into minus 1 will give you plus s square, and minus into plus will give you minus 9 divided by s square plus 9 the whole square. This is our final answer. Now to find Laplace of t square into sin t, we know that Laplace of sin t or sin at, it is given as 1 upon s square plus a square. Here the value of a is 1, so it will be 1 upon s square plus 1. Now since t square is multiplied, we can use the multiplication property. Considering this function as f of s, Laplace of t square into sin t can be written as minus 1 raised to 2 into now second order derivative. As the power is 2, it will be second order derivative of f of s. Minus 1 the whole square will give you plus 1. To find directly second order, we need to first find the first order derivative. So keeping one derivative as it is, let us find the derivative of 1 upon s square plus 1. For that, you can use UV rule, or you can directly compare this function with 1 by x. Now 1 by x derivative is minus 1 by x square. Similarly, this derivative will be minus 1 upon s square plus 1 the whole square into derivative of s square plus 1 will be 2s, as it is a composite function. Now we need to again find the derivative of this function, that is minus 2s upon s square plus 1 the whole square. You can take minus 2 outside, and the remaining part will be carried out using u by v rule. Using u by v, we have minus 2 into s square plus 1 the whole square, derivative of s minus s as it is, derivative of s square plus 1 the whole square, divided by v square. Minus, we have s into, comparing this with x raised to n, we have nx raised to n minus 1 into again derivative of s square plus 1 will give you 2s. Here we have 2s into 2, that is 4, into s will give you 4s square. This becomes our final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.